Okay everyone, welcome to part 2. This is going to be the second part of the build series for the Terminator SLA DLP printer. So in this part we're going to go over building the frame or assembling it. So to get started, you need to obviously have a chop saw that's very square. Make sure it has a carbide blade because that's going to give you clean cuts through aluminum. I would recommend cutting the aluminum dry, don't use oil. And if you can, these rails here, like for example the top rail, bottom front rail, and then these back rails, basically all 6 of these rails here that I'm crossing, I would cut them all together if you can. So if your chop saw has the capacity to cut that diameter or width, go ahead and just tape these all together and cut them all at once. But also you're going to have multiple sticks of aluminum, so you may not be able to do that, but cut as many as you can together because you'll end up with a better match between the links. And then also the same obviously for the side rails here. If possible, cut them together when you can without wasting aluminum profile. Let me skip ahead here to a picture. After you cut them, the end of them should be perfectly square, granted your saw was set up correctly, and you're going to need to tap each one with threads on both ends. So all of them are tapped because the little cube corner connectors that are going to go right in here require obviously bolts that run into tap threads. So you're going to need an M5 tap. You can use a drill tap that you run with a drill, but if you do that, I would highly recommend using actual cutting oil. Make sure not to don't use motor oil or like some other type of oil. Buy actual cutting oil so that they don't jam. I was cutting the threads with a drill at low speed, and I wasn't using cutting oil, and it actually broke off the tap, and I had to basically scrap that piece and cut another piece. So make sure and use cutting oil if you're going to use a drill. And even by hand, it's probably a good idea to use cutting oil because it just makes it so much easier to tap the threads. Aluminum's not easy to tap. It's soft, but it doesn't like cutting threads. The aluminum starts clogging up the bit, so you have to tap, quarter inch down and then back it out and run it back in again. So tap your threads with cutting oil, and then make sure and use when you're done, or actually before you tap, just take a countersink bit like you would use for wood. And you can see this little bevel here. Just countersink the end of each rod on both ends quickly, and what that does is it makes sure that when you tap down into here, you don't get a metal burr sticking up that's going to run into the corner cube. So when you connect these to the corners, you don't want anything protruding out from the end here hitting the cube, or you're going to get a mismatch when you try and get it to sit flush. So countersink the end of each one quickly with a drill, and then tap your threads with cutting oil. And granted, everything was nice and square. You should have a nice square frame when you get done. It looks something like this. Just ignore these rails for now. These are the 2 support rails for the Z-axis. But basically what you want to do is get these 2 front rails, this rail and this rail to back rails, and the 2 side rails. So basically all 8 of the outer rails connected with these corner cubes, and obviously these little posts here that go in between. These little posts are 150 millimeters, so you want to get all of those connected as well. So you basically want to have a rectangular box, and then you want to check it with a T-square. Make sure all of the surfaces right here where you transition from a rail onto a corner, make sure that they're flush. Feel right here with your finger and make sure they're flat, because you can actually connect these, and there's a small amount of movement. So make sure everything is nice and flush where it connects, so you don't run into issues later when you go to mount the case. And make sure with a T-square that all these corners are square. And then after you're good with that, basically you just put these right angle connectors onto the left and right, or should I say the top and bottom rails here for the Z-axis, and you can slide them down into here and mount them. But I'm going to go over now which of these captive nuts. You can see these captive nuts laying down in here. You have to insert these before you assemble the frame, because after the frame's assembled, you can't slide them into the track. And they do have drop-in T-nuts, but they're very expensive compared to the slide-ins. And they also don't have as strong of a grip, in my opinion, because they don't have as big of a footprint. So it's better to use these for the frame because you need to make everything really tight and make sure it doesn't get loose later on when the machine's running because of the vibration. Harmonic vibration from the motor, that is. So I'm going to go over now where to put those T-nuts before you assemble the frame. Okay, so now before you assemble the frame, I'm going to show you guys where to put the T-nuts and how many of them so that you don't have issues later on. And of course, this only works if you build it the same way I built it. So if you make modifications or you want to change something out, you might end up taking the frame apart later, or using the slide-in, or the I forget what they call them, but the T-nuts you can insert, and as you tighten them up, they spin. So anyway, that's starting into here. And I'm also going to go over the length of the rails for the frame because they're in the bill of materials, but just to make it easier, so these front rails here are going to be 300 millimeters long. So if you cut 6 of these, you're going to end up with 2 front, 2 back, and 2 supports here for the Z-axis. So cut 6 of these at 300. These little ones in the vertical parts here, those are going to be 150. So cut 4 at 150 millimeters. And then the rails here on the sides, you're going to cut 4 at 340 millimeters. And the 2 Z-axis rails here are going to look different than this because this is obviously before I finish the printer. And I changed these out to 20 by 40s, so they're double on this dimension, so they're a lot stiffer. So you're going to cut 2 of these Z-axis rails at 750 millimeters. And that'll be it, pretty much. That's all you have to cut. So now let's go on to inserting the captive nuts. So in these top side rails, you are going to insert, so this rail here, this is the top side rail, you're going to insert 3 captive nuts into the top and 3 nuts on the inside. So on the this would be the inside of the rail here, this part. So 3 on the inside and 1 on the outside. So this would be the outside of the rail. You're going to insert 1 nut here. And on the left rail, you're going to insert 2 on the bottom. So on this rail here, which would be the left rail when you're looking from the front of the machine, which is over here, and you're at the front of the machine looking here, this is the left rail. You're going to insert 2 of these little captive nuts on the bottom of the rail as well, because the fan mounts down there later and you need those. So that's it for the top side rails. For the top front rail, which is this one here, you're going to insert 4 captive nuts into the top only, and that's it. So there's 3 here, but you're going to need 4, so insert 4 into the top. The top back rail, which is this rail here, you're going to insert 2 of them into the bottom of the rail. So on the underside of this rail, put 2 of those. On the bottom side rails, so these guys here, you're going to insert 1 on the outside. So 1 on the outside here, 2 in the top of the rail, so 2 here, and 1 on the inside. So on the inside of this rail, the bottom side rail, put 1 captive nut on the inside. On the top and bottom Z-brace rails, which are going to be these, I'm calling these the Z-brace rails because that's what they do, they hold or brace the Z-axis. You're going to insert 4 captive nuts into the front of each one. So in the front of this rail, which would be over here, I'm just going to draw this really quick. So right here, which would be the front of the rail, you're going to insert 4 of them in the front, and those are going to allow you to connect these corner cubes later. So you need those in place before you continue. On the Z-axis rails, which are going to be these guys here, you are going to need 2 captive nuts on the outside, which this is the outside, so they're going to basically connect to these corner cubes, this one and this one. So put 2 on the outside, And you're going to get 2 of them into the back, which should be on the back side here. This is the back side. And you're going to put 1 on the inside. So this would be, draw real quick here. This would be the inside of the rail. You're going to put 1 on the inside of each rail. Okay, so now that you're done putting the captive nuts in the rails, you can go ahead and assemble the frame, because you have to do that before you assemble it, obviously, like I mentioned earlier. So get that done, assemble the frame, make sure it's all square. After you check the outside, make sure it's square. You can go ahead and place these rails in here. I'm going to have to put the distance here from the back of the rail to the back of the machine in the notes for the video, because I don't know how far this is. I forgot to measure this. So I'm going to add that, and after you're done mounting these Z support rails, you also want to check with a T-square in this corner here. So this corner, you want to check in this corner here, where I have red, and this corner here on both rails, the top and the bottom, and make sure with the T-square that they're perfectly square. And then you can go ahead and mount your Z-axis rails right here where this arrow is pointing to the corner connectors. And what you're going to have to do is, after you mount these rails, just tighten them down firm but not hard. You're going to have to connect the Z-axis rails, but don't tighten them. Just connect the corner cubes right here and right here. So you're going to connect it right here and right here on both rails. And then you need to actually assemble the gantry plate with the arm. You need to assemble at minimum the gantry plate here, even without the arm, so that you can position the width of these correctly. There's no way to set this width and have it fit later without having this in here. So you're going to have to skip ahead to part 3, which is printing all of the parts on an FDM printer. And I'm going to go ahead and show you guys what the new one looks like, because this gantry here, let me see if I can pick a better spot to show you. Okay, so this gantry right here with the 4 wheels on it, that's not the one that is used in the final printer, because I started out using the mini V wheel plate from Open Builds, but the problem is it doesn't have enough Z height to provide a stable base for this arm. In other words, the length of this arm is much too long for the height of this plate, and it starts twisting it around. It's not stable enough to give you a platform that doesn't move around. So I ended up redesigning my own plate that's 2 or 3 times taller, so the wheels are spread further apart, and it gives you a much firmer platform to roll on, and the arm doesn't have a chance to get any leverage advantage on it. So you're going to print this. This is a little different, but it works pretty much the same. It's just a lot taller. So I'm going to skip over here and show you guys a picture of it. So this is the printed version, and you need to print this in a carbon fiber filament. If you print this in regular filament, it's not going to be stiff enough, so this has to be pretty much 100% solid, in the sense that it's very rigid. You don't have to print it completely solid. I think I printed it with 40 or 50% infill, triangular infill, but just check the Thingiverse page for the print settings, and you're going to print this black part here in carbon fiber filament. Attach your 4 wheels. There's a little rotating, like an offset nut on one side that allows you to basically adjust the width of the wheels in or out. I believe I set mine all the way to the outside. So whatever direction sets this wheel the furthest out in this direction here. So let's say, actually for example, let's just say this was the nut here. It's not, but let's say this was the nut that allows you to move the wheel back and forth. It's called an eccentric spacer, I think. You're going to want to put that nut in the position where the wheel is the furthest in this direction. In other words, outwards. So you want these wheels as far apart as possible. And then go ahead and snug these nuts up. Make sure that they're tight enough so the wheel cannot wobble around. You don't have to crush them, but just set them very, very tight so they don't have a chance to wobble. And this whole plate here, the black part, is all one piece, so it should when you get done, you're going to have one big block that looks like this. You're going to slide the 8mm ACME nuts into the end. You may have to ream the inside with the drill bit. I forget the drill bit size, but just pick the closest size to the hole and ream it out. If these don't slide in, they should slide in, but if they don't, you'll have to ream the hole a little bit. And then mount them with, I think these are 3mm screws. So you don't have to clamp them all the way down here against the surface. You don't have to make them flush like this, but get them close. And for now, you're not even going to insert this rod. You don't need this rod for now. All you need is just to have this assembled so that you can put it in between the Z-axis rails. So if you want to attach and print the arm as well, it'll look something like this white part up here, although I would recommend printing it in carbon fiber as well, which is what I eventually used because everything else moved a little bit too much. It was too flexible. So if you want to, go ahead and print this arm. It's also on the Thingiverse page, so print this in carbon fiber filament as well and attach it, but you don't need to. So after you get that done, then you're going to come back, and the way you're going to do this is you're going to lay it on its back like this. You're going to lay the frame on its back, because this is the easiest way to do this. And you're going to basically take the platform, or the gantry, put it in between the rails, and you're just going to put tension on the rails with your hand so that it can't fall out. And you're going to put the gantry right here. Just ignore this motor. This motor doesn't go here in the final design. So you're going to put the gantry plate right here. And you are going to set these screws here. Go ahead and snug them up with the gantry plate touching both rails. So you're going to hold the rails together with your hand pretty firmly. Tighten these up, but do not tighten these bottom ones yet. Leave these loose or semi-loose. So now that you have these clamped with the plate in between and there's no slop, make sure there's no play. If you wobble, if you have the gantry wobbling around, they're not snug enough. So make sure the gantry can't wobble in this position. And then what you're going to do is you're going to essentially slide the gantry plate down. So slide it this direction until it's roughly here at the bottom. So you want it down here now. And then you're going to spread these two rails, spread them apart slightly so that there's a little bit of play in the gantry wheels. And the reason you're doing that is because you want tension on the rails up here, the upper rails, because if you don't have tension up here, you're going to have issues when the gantry runs up here. If this is not touching the wheels at all times, you're going to have play, and that's going to end up in movement in the head of the printer, which is going to cause print problems. So you want these rails slightly too close together at the top, which will give you a constant tension against the wheels. So you're going to get a little flex in the aluminum, but that won't matter because the tension between the left and right is going to be equal. So there will be no movement. So what you're going to do is put the gantry plate down here. Make sure you got a little slop or play. Go ahead and clamp these brackets as well now. These guys here. And then after you're done with that, make sure take a ruler or whatever you can use to measure accurately and measure between the side here and the inside of the frame. Measure that. Make sure this other part on the other side, like from here to here, make sure this distance is identical to this distance, whatever it happens to be that you choose. So let's say this distance up here was 30 millimeters, for example. We would want this one to be like 29 or 28 millimeters. So it's not going to be a big difference, but it's going to be slightly smaller. But you want to make sure that this bottom one here and this other bottom one here match. That way you know for sure that you've got an equal amount of tension on both of these rails, so that your gantry goes straight up when it goes up and there's no movement left to right. Because if these rails don't have even tension, you're going to have a little bit of movement on the x-axis, in other words, because your gantry will shift slightly, so you don't want that. So essentially when that's done, you should be able to slide this gantry plate from here. You should be able to slide it up and down freely with your hand. There should be no binding. If there's binding, you either have these rails too tight, or you have the wheels on the gantry, which I showed you guys earlier, if you have these wheels tightened too tight, they will also get some drag. So don't crank them down too crazy. So go back here to my notes. Make sure that it slides freely with your hand. Right here I'm sliding the original one up and down freely to make sure that there's no play, and also make sure that it's not binding up. And then that's pretty much it. There's a joiner brace for the top of the rails that you're going to attach later, but that's not necessary to continue the assembly, so you can attach that later. So that's pretty much the main part of the frame. By now you should have everything tight on the frame. The only last thing you want to check is, go here and get rid of these other notes. See if I could find a better example here. See if I have a better spot. This is probably the best place to show you, is right here. When you get everything assembled, take a plumb line, which, if you don't know what that is, it's basically a string with a weight on the end, and you use that to determine when something is perfectly vertical. But put a plumb line, connect it with some tape or something right here. Start drawing again here. Connect it right here with some tape so that it comes right here and drops down through this hole, and it's going to be hanging down under the printer like this, and you're going to have your weight down here, whatever it happens to be. And what that's going to do is it's going to tell you if you have any twist in these rails, because even if your frame is perfectly square, if you don't get this rail here, the top rail, and the bottom rail, if these are not perfectly parallel, in other words, if you're looking down here from the top, if they don't line up perfectly with each other, you're going to have twist in the vertical rails, which means that the vertical rail could twist this direction, or as a set they could twist in this direction, for example, and that'll mean that this arm that's sticking out here will move to the left or possibly to the right as it's going up and down, because your rails are not perpendicular. So geometrically this is a little bit fun, but this is the easiest way I know of to get this perfect, and that is put a plumb line on here and set it up so that it's swinging right above the bottom, and you're going to put a piece of paper or something down here on your table or work surface or whatever it happens to be, and you're going to mark right underneath the plumb when it's hanging straight down. And from there you're going to roll this gantry, so take the gantry here and roll it up and down, and make sure as it goes up and down, try and roll most of the axis. So like, for example, from here, which is the build platform, go almost to the top out here where you can't see, and make sure that this plumb line doesn't move. So you want to make sure that this weight is constantly centered over your crosshair down here that you wrote on your piece of paper, and obviously you might want to tape the paper as well so it can't move. But roll the gantry to the top, and you may not, actually I said to tape this earlier, but you may not want to tape this, and the reason is you want to let out some slack. So if you want to, just hold this with your finger lightly and just let out some slack and let the weight further down, because this weight's going to lift up in the air obviously when you roll it up, and make sure that it still touches this. If it doesn't still touch the same spot, in other words, if it's shifted over here to the left or to the right, then you know that you have twist in these rails and you need to correct that. So to correct that, you would move either the bottom rail or the top rail on the respective side to correct the twist. So for example, let's say that your weight right here moved to the right by 3 millimeters, which is pretty bad, but let's say it moved that far. Okay, so if you wanted to correct it moving 2 or 3 millimeters to the right, you would either have to move this top rail forward, or you'd have to take the other side of the top rail over here and move it backwards to correct that. And so ideally, when these are perfectly square and perpendicular with everything, this plumb will never move. You roll the platform up and down, it stays in the same spot here, the weight, regardless of the height. You know you have everything perfect. Get the frame locked in tight and don't move it. Don't disassemble it, because it's going to stay that way through the assembly. So that's pretty much it for the assembly of the frame. This is obviously before the printer was finished, so I used to have an aluminum bed here. I had a friend cut it on a machine, like a CNC-like machine. And I ended up not using it because in order to cut a plate out of aluminum, you could actually use the files I have uploaded on Thingiverse if you have access to a CNC, and you could mill it out of aluminum, but I don't have access to a CNC, so I 3D printed them, and they seem to work just fine. So if you want to do yours out of aluminum, just take the STL files and join them. I would take the left and right file because they're two separate pieces, and just join them together in your mesh editing software. And then go ahead and CNC them out of aluminum if you want to, but I had mine just printed out of carbon fiber. So that's pretty much it for the frame assembly. Skip through here a little bit, see if there's anything I forgot to show. Don't think so. You are going to mount you are going to mount the motor later, but we'll get to that later. So the motor, when in the final design, actually goes. Skip back here. This motor actually goes down here below the rail. I had to change that, so just ignore this, so it doesn't go here.